In this video, we're going to look at adding, subtract, and multiply complex numbers. You can also divide complex numbers, but that's a little more complicated, so that's in the following video. And the first thing we do is we have to have a basic rule to remember. And here's the basic rule that we need to memorize. And that is algebra with I. To do algebra with I, you simply follow this rule. You pretend that I is a variable, like x, until you have I to a power. And then you can always simplify. So that may not make sense at first, but as we go through examples, it will, and that rule will always work. Anytime you're doing algebra with I, then you pretend that I is a variable, like an x, until you get I to some power, and then you're going to just simplify it. So let's look at an example. And the first example let's look at is, let's do a multiplication problem. So let's do 3i times 5 minus 4i, right? So notice that this is very much like this problem, 3x times 5 minus 4x. It's not exactly the same, right? How it's different is this has I in it and that has x in it. But let's look at our rule. Algebra with I is that we pretend that I is a variable like the x until we get I to some power. And then once you get I to some power, you're going to simplify I. So let's look. If we were doing this problem over here, the first thing that we would do is we would simply distribute, right? We distribute this to this and this to this. And then that would be 3x times 5 would be 15x. 3x times negative 4x would be minus 12x squared, right? 3 times minus 4 is minus 12. X times x is x squared. So there's nothing complicated about this. The trick here is there's not a lot complicated about this. We're going to notice the I. We're going to pretend that I is an x. It's not, but we're going to pretend it is. Then you distribute, right? And when you distribute, you get 3i times 5 is going to be 15i. 3i times a negative 4i is a minus 12i squared. Now if you notice, we're done with our algebra. If these were x's, we would be finished. But now we're going to remember the second part of the rule, and that is anytime you get I to power, we're going to simplify it. So what is I squared? I squared is something you should have memorized, right? I squared is minus 1. You want to memorize that. So if I squared is minus 1, then we have 15i times minus 12 times minus 1. Negative 12 times negative 1 is a positive 12, so you have 15i plus 12. Now that's your answer. Typically we would like to write it in the form, so this is correct, but we want to write your answer as a plus bi. That is, we want to write the real part first. So that's going to be a 12 plus 15i. And that's going to be the final answer that we want right there. And that's all there is to it. That's how you multiply complex numbers. Let's look at an example of adding. Adding is even simpler. Let's do 5 plus 3i plus 7 minus 2i. So again, the rule that we're going to remember is that we're going to pretend that I is a variable, like an x, until we get I to some power, and then we're going to simplify it. So let's think about this. What would this be if instead of i's, those were x's? Well, in that case, these are like values, the 5 and the 7, so that's going to be 12. And the 3i and the minus 2i are like terms. So that's 3i and minus 2i is a positive I. And we're done. Let's do an example with subtraction. 6 minus 4i minus 12 minus 7i. Again, pretend that the i's are x's to start with. Well, the first thing we're going to do is, this is a negative, so that's like a -1. We're going to distribute the negative sign. And we do so, we'll lose the parentheses, so that's 6 minus 4i minus 12 plus 7i, right? If you notice that a negative and a negative becomes a positive. Then we're just going to combine like terms. 6 minus 12 is going to be minus 6. Negative 4i and positive 7i is going to be a plus 3i. We're going to make sure it's written in the form a plus bi, right? That's the way we want to write it. Is the real parts first and then the imaginary. We're done. That's all we're going to do. So both adding and subtracting with complex numbers is very easy. You simply treat it just like you would if there were variables, except whenever you get a square root, whenever you get an imaginary number, a complex number, you're going to simplify it. When you get a complex number to a power. Let's do a somewhat harder problem. Let's do a FOIL problem. So it'll just say simplify 3 plus 5i, 2 minus 7i. So here we're going to use FOIL, or however you treat this just like they're x's. So it's 3 times 2. 3 times 2 is 6. That's the F. You have O. O stands for outside. So you have 3 times negative 7 is minus 21i. You have FOI for inside. 5i times 2 is 10i. And lastly, you have the last one, L. So that's 5 times negative 5i times negative 7i is a minus 35i squared. I'm going to keep treating these like they're variables. If these were like variables, this is 21i and 10i. You simplify those. You combine those two to be a minus 11i, minus 35i squared. But notice we have an I squared, and I squared is equal to a minus 1. So you have 6 minus 11i minus 35 times minus 1. That's going to be 6 minus 11i. A negative times a negative is a positive, so that's going to be a positive 35. We're going to combine like terms. This is 6 and this is 35, so those combine. So that's going to be minus 11i plus 41. That's correct. We like to write it in the form a plus bi, so the way that we're going to write is we're going to put the real part first, and your final answer is 41 minus 11i. And that's how you add, subtract, and multiply complex numbers. There's a following video that just goes through a couple more examples. That's add, subtract, and multiply complex numbers part 2. So watch that next.